Hello everyone, welcome to our show. This week we're gonna start with the science episode, cracking the mystery code. Are you guys ready?
Yes.
Okay, welcome Indra and Netra. We have two special guests today, Ashi and Reenu. Ashi, why don't you tell something about yourself? Grade?
So I'm in grade 8 at Hillcrest Middle School, and I am very excited to be joining you today on this episode of Special Sevens.
Wonderful, thank you. And Reena?
My name is Reena. I'm in grade 9 at New Westminster Secondary School, and I'm very excited to be here today.
We are equally excited to have you all in the show. Let's get started. Today we are going to learn about magnets. Do you guys know what is lodestone? Anybody?
No.
Okay, lodestone is a stone. Okay, so where did we first find magnets? So this is how the story goes. At least it's a theory. There was a person who was walking on the mountains of Turkey, and he found a stone. He was walking his goats around, and then he found a stone, and the stone seemed to attract the nails in his shoes. And he was wondering what's happening, how is this stone attracting, and that stone is called as lodestone. And this stone has magnetic properties, and it was originally found in Turkey. What does it mean when you say a particular object has magnetic properties?
It means it attracts something.
Attracts something. What thing specifically? Plastic?
Something else that's magnetic?
Metal, exactly. So what is a magnet? A magnet is a piece of thing that can attract other metals, right? And usually magnet has poles, correct?
Yeah.
What poles?
North and south.
North and south. And what poles attract? What poles repel?
North attracts north, south attracts south.
The opposite, actually.
Attracts.
The opposite poles attract.
Yeah.
Okay, correct. But you are right. So how can we make a magnet? Okay, so we found a stone, a lodestone, but what we have at our home magnets, they are not lodestones, right? So how can we make magnets? Let's start by understanding how to make a temporary magnet. Let's say you already have a permanent magnet. If you take a piece of metal like a nail and rub it against it for a few minutes, this nail automatically becomes a magnet. And here you can see how this nail, even though it has come off the magnet, it's still attracting paper clips.
How much time does it attract?
That's why it's called temporary. So it loses its property after some time. But this is a way for you to make temporary magnets. Okay? Now let's see what is an electromagnet. This is the second kind of magnet. What do you guys know electromagnet? Yes, Sashi?
Yeah, I did an experiment at school.
Oh, nice. What is electromagnet?
It's like magnets that it has to do with like electricity,
Uh-huh.
where you like attach like tin foil to like a battery or something to
Okay.
like light up another thing or to like attract things to the magnet.
That's right. Okay. So here you can see in this picture there is a battery and there is a piece of coil that is wrapped around a metal like a nail. So now when the battery's power enters the coil, it influences the nail and the nail becomes a magnet. So you are making a single piece of metal into a magnet with electricity, electromagnet. Okay? This is how some cranes work in car junkyards. That crane, the operator turns on a switch and then it becomes a magnet, it attracts things, and then he turns off the switch and it drops it. So this is a electromagnet. This is the second type of magnet that we saw. But how do I make permanent magnets? For example, do we have magnets in our home? Any examples?
Yeah, like on the fridge?
Correct, refrigerator magnets. They are always magnets, right?
Yeah.
You don't need electricity. It's not temporary. So how was it made? So this is how they make permanent magnets. They take a mix of metals like aluminum, nickel, cobalt, copper, iron, titanium, these are all metals. You heat them all together until it becomes like molten lava, and then you pass electricity into it, and then it becomes a permanent magnet. But it's a heavy process that has to be done in a factory. So once you heat them all, it is now a liquid like a molten lava. You can pour it into a cast like how you do with Play-Doh. You make it into any shape you want, and then you pass electricity into it, then it becomes an electromagnet. That's how magnets are made. So we saw 3 types of magnets: temporary, electromagnet, and permanent magnet. Okay, so now let's see, where do we use magnets? Reena already mentioned fridge magnets, right? And compasses. Do you guys know compass?
Yes.
Yeah.
Compass has a magnet, right? That's how it shows the true north. And credit cards have magnets. Did you guys know that?
No.
The black strip that you see in a credit card is called a magnetic strip. And the machine that you swipe it in, it has a magnet to read it. That's how we can find the exact digits of the credit card. And all phones have magnets. Here you can see this is the phone. This is the same phone with a magnetic strip. So it displays the magnets there. All these blue things are magnets. Why do phones have magnets? Okay, so this is very interesting. Any speaker or anything that you hear sound with has magnets. Why? When I speak, what I'm emitting is sound, right? That sound gets converted into electricity by a mic or a receiver, and that electricity, when you pass it into a magnet, based on how the waves are, the magnet vibrates, and then you can convert that vibration back into sound. That's how when I'm talking into a mic, even though I'm talking so low, through the speaker you hear it with a more volume, right? So just remember this, all mics and all speakers have magnets in them. Another interesting thing is the MRI scanner. Have you guys heard about it?
No.
So MRI is, Sashi, where do we use it?
In hospitals.
In hospitals, exactly. So if I want to see your bones, how do I do it?
X-ray?
X-ray. But if I want to see your brain, how do I do it? And scan, MRI scan. An X-ray cannot find your brains. It only finds your bones. So MRI means magnetic resonance imaging. Okay. So these magnets, they scan your body and they make a picture of your brain. So anytime somebody goes for an MRI scan, then we are using magnets. So you see how magnets are useful for us in so many things, right? Do you guys know that Earth is a magnet? The whole Earth is a magnet. It has a North Pole and a South Pole. That's how the compass works. So if I ask you, where is Earth's North Pole? Where is it? North, right? So if Earth's North Pole is in the north, then imagine the compass magnet. North and north should repel, right? So the North Pole of the compass should point down. But why is it pointing up?
Because the magnetic.
Because at the end of the thing is it like South Pole kind of, like at the end of the
Okay.
thing, like a.
Or any theories from anybody else? Okay, let me explain. So Earth has a geographic North Pole. Geography means that's what we use for maps, and has a magnetic North Pole. Earth's magnetic North Pole is actually in the south, red. Earth's magnetic South Pole is in the north. So it is actually flipped. The actual North Pole of the Earth is the magnetic South Pole. That's why the magnet's North Pole points always up. Okay, just remember this, that Earth is a magnet, and that's how compasses work. So that's how people used to look at the compass and find the direction in which they go. Some of the birds also are able to read Earth's magnetic field. Somehow they have a compass in their brain, and that's how they migrate and they go to their destination and then they come back. So it is very important that the Earth has its magnetic field. And do you guys know the Northern Lights? Yeah, we will explore that in another episode, but just remember this: we see Northern Lights only because Earth is a magnet. Okay? Now, Curiosity Corner is when I'm going to ask you guys a question. What happens when I break a magnet into two pieces?
It immediately gets two sides, like a south and a north side.
Now there are two pieces. Are you talking about each piece?
Yeah.
So, you're saying when I break a magnet into two, I get two magnets? How many of you agree?
When you break it in half, the magnet connects itself.
Connects itself, okay. That's another theory, okay. But you still think that the two pieces are still magnets. It does not lose its magnetic property, right? Okay. Okay, Indra, you are correct. Netra, though, it doesn't connect. It starts to ripple. The moment you break the magnet, this becomes north, this becomes south, north, south. So it actually attracts. You're right. I'm sorry. So what happens here? The broken pieces, they try to attract each other. If you flip it, then it ripples. Okay. So Indra, Netra, both of you were right. I got confused. I'm sorry about that. Okay. Is that clear? So what happens when you break a magnet? You get two magnets which wants to try to attract each other again. But it gets its own North Pole and South Pole. So basically, if you break a compass into two, now you have two compasses. Okay? Okay, good. So, any questions about what we saw today about magnets? Okay. Was it interesting? Yes, Indra.
Is the electromagnet powerful than the other one?
That depends on how much electricity you pass into it. If I connect one battery or two battery or 100 batteries, that's how powerful the electromagnet is. Okay? Okay? So, let's go around and you guys can try and remember one of the facts that you learned today and you can tell. Who wants to go first? Yes.
Earth is a magnet.
Earth is a magnet. Very good. Reena, what do you remember?
If you break a magnet, you have two magnets and they try to attract.
Correct. Netra?
Magnets are useful in lots of ways.
Okay. Any particular thing that you remember?
Like in a credit card or phone.
Very good. Yeah, credit cards have magnetic strips.
There is
Ashin?
a geographical North and South Pole and a magnetic North and South Pole.
Correct. They are the opposites.
Yeah.
Very good. Wonderful. It was such a pleasure having you guys learning about magnets. We will explore another topic next week. Thank you very much, everybody. Bye.
Bye.